At the edge of Beijing, there is a factory that does not sleep. At midnight, its production lines are still moving. Robotic arms lift delicate components with microscopic precision. Driverless carriers glide through empty corridors. Artificial intelligence watches thousands of machines at the same time, searching for defects invisible to the human eye. But there's something missing. No crowds arriving for the night shift. No operators standing beside the conveyor belts. No supervisors shouting above the machinery. In parts of this factory, even the lights are unnecessary. Every few seconds, another smartphone reaches the end of the line. Tested, inspected, packaged, ready to leave. This is Xiaomi's smart factory in Changping, Beijing often described as a dark factory, where machines can perform much of the production process with minimal human involvement. But the real story is not how many workers have disappeared from the factory floor. The real story is what has replaced them. Because this building is not simply filled with robots. It is controlled by a digital nervous system that can detect problems, adjust production, and coordinate machines before a human engineer even knows something has gone wrong. And if this system works at scale, China may have created more than an advanced smartphone plant. It may have created a blueprint for the factories that could reshape global manufacturing. The question is no longer whether robots can build products. The question is what happens when the factory itself begins making decisions. Part 1. The factory that never sleeps. From the outside, the complex in Beijing's Changping district does not look like the beginning of an industrial revolution. There are no giant smokestacks, no mountains of steel, no endless lines of workers moving through security gates. The buildings are clean, controlled, and almost strangely quiet. Yet inside, an enormous production system is operating around the clock. Xiaomi says the facility covers approximately 81,000 square meters of production space and is designed for an annual capacity of around 10 million high-end smartphones. That number is difficult to imagine. 10 million phones in 1 year would mean producing more than 27,000 devices every day if output were spread evenly across the calendar. That works out to roughly one completed phone every few seconds. But speed is only one part of the story. Traditional factories increase production by adding more workers, longer shifts, or additional assembly lines. The Changping plant is built around a different idea. Instead of depending on thousands of human decisions, Xiaomi has connected much of the factory to a central manufacturing platform. Machines report their condition. Automated vehicles deliver components. Software tracks production in real time. When one section slows down, the system can identify the bottleneck. When a machine begins behaving abnormally, maintenance teams can be alerted before a complete breakdown. When a defect appears, data can be traced backward through the production chain to find where it began. This is why the phrase dark factory can be misleading. The factory is not completely empty. Engineers, technicians, maintenance specialists, logistics staff, and other employees remain essential. Some areas still require human support. Robots need calibration, equipment needs repair. Production plans need approval. New products must be introduced and tested. The darkness is not proof that humans have vanished. It means some production areas can continue operating without the lighting, movement, and constant physical presence required by traditional human-centered assembly lines. That changes nearly everything. A human worker becomes tired. A robotic arm does not. A person may lose concentration after hours of repetitive inspection. Machine vision camera can examine component after component using the same programmed standard. A shift change may temporarily slow a traditional factory. An automated line can continue moving. But what happened next transformed the factory from a collection of machines into something far more powerful. Xiaomi connected those machines to an industrial intelligence system known as Hyper-IMP. Think of it as the command center of the operation. Across the factory floor, sensors constantly produce information: temperature, pressure, vibration, speed, alignment, component position, electrical readings, inspection results, production volume, machine status. Individually, these numbers mean very little. Together, they form a live digital picture of the factory. Hyper-IMP is designed to collect and interpret that picture. Instead of waiting for a human supervisor to walk through the plant and discover a problem, the system can monitor production continuously. That does not mean it possesses human consciousness. It does not understand the factory in the way a person understands a workplace. It follows models, rules, and algorithms created by engineers. But within those limits, it can react faster than any human management team. Imagine one robotics station beginning to place a component a fraction of a millimeter outside its intended position. The phones may still look normal. The line may continue running. Several stages later, that tiny error could create a major quality problem. In an older factory, workers might discover the issue only after hundreds or thousands of units had been assembled. In a connected smart factory, inspection data can reveal the pattern much earlier. The system can flag the machine. Engineers can trace the defect. Production can be adjusted. The damaged output can be isolated before it spreads through the entire operation. The result is not simply faster manufacturing, it is manufacturing that can watch itself. And that is when the empty corridors begin to feel less like science fiction and more like a warning from the future. Part 2. How a phone moves through the dark. A modern smartphone may fit inside one hand, but producing it requires one of the most complicated supply chains on Earth. Hundreds of components must arrive with extraordinary accuracy. Processors, memory chips, cameras, batteries, antennas, sensors, circuit boards, speakers, glass panels, metal frames, connectors smaller than a grain of rice. A single phone may contain parts from numerous suppliers, each operating under strict timing and quality requirements. If one critical component arrives late, production can slow. If one batch is defective, thousands of finished devices may be affected. And if a new model launches with a hidden fault, the financial damage can reach far beyond the factory. This is why automation begins before the phone is assembled. Components entering the facility must be identified, tracked, and moved to the correct location. In highly automated areas, intelligent storage and logistics systems manage that flow. Automated guided vehicles and mobile robots transport materials through designated routes. They do not stop for lunch. They do not search for a missing pallet using handwritten paperwork. They follow digital instructions linked to the production schedule. Picture the factory from above. Rows of machines form carefully planned corridors. Small driverless carriers move between them like blood cells traveling through arteries. Each one carries the right material to the right station at the right time. If one production area needs more components, the request can be generated automatically. The real mission has only just begun. Before a phone can take shape, its main circuit board must pass through surface mount production. This is one of the most delicate stages. Electronic components must be placed onto the printed circuit board at extremely high speed. Some are almost too small to see clearly without magnification. First, solder paste is applied to specific locations. Then high-speed placement machines lift tiny components and position them on the board. The board enters a reflow oven, where carefully controlled heat melts the solder and forms electrical connections. If the temperature rises too quickly, components can be damaged. If it remains too low, connections may be weak. If a part is placed slightly off-center, the board may fail later. Machines monitor the process. Cameras inspect placement. Automated optical inspection systems compare the board against expected patterns. They look for missing components, incorrect orientation, damaged surfaces, and imperfect connections. But that was not even the most difficult inspection. Some solder connections are hidden beneath chips and cannot be examined from above. Manufacturers may use X-ray inspection to look through the component and examine the joints underneath. On a screen, the circuit board becomes a shadowy landscape of lines, circles, and metallic connections. Software searches for abnormal shapes. A void inside a solder joint. A bridge between two contacts. A missing connection. A defect that might survive ordinary visual inspection. Every rejected board becomes information. Why did it fail? Was the solder paste uneven? Was a placement nozzle misaligned? Did the oven temperature drift? Did the component arrive damaged? In a smart factory, the answer should not remain trapped at the inspection station. The data can be sent back through the production system. That feedback allows engineers and increasingly software to identify the source. This is where the factory begins behaving less like a fixed assembly line and more like a living network. Every stage can influence the stages before it. After the circuit boards are completed, other parts of the phone begin coming together. The frame is prepared, cameras are installed, flexible cables are connected, Speakers, vibration motors, and antennas are placed into position. The battery is inserted, and the display is attached. Adhesives must be applied with extreme consistency. Screws must be tightened to controlled torque levels. Too loose, and the device may fail. China's scale gives it an enormous testing ground. When a new robot succeeds, it can be deployed across thousands of production lines. When an industrial software system improves, it can influence millions of products. When a factory generates data, that data can train the next generation of machines. This creates a cycle. More factories produce more data. More data improves automation. Better automation attracts more investment. More investment creates more factories. The cycle can accelerate faster than traditional industrial development. And once it begins, the competition is difficult to stop. Part 7. The last light returned to the Changping factory after midnight. Outside, Beijing continues moving. Cars cross illuminated highways. Apartment towers glow in the distance. Millions of people sleep, work, and live around one of the largest cities on Earth. Inside the factory, machines continue their precise choreography. A robotic arm lowers toward a circuit board. A camera flashes. Software examines the image. A driverless carrier turns into another corridor. A phone powers on for the first time. Its screen lights up. For a few seconds, that small display may be the brightest object on the production line. Then the device moves forward. Another takes its place, and another. To the customer who eventually opens the box, the phone will feel personal. It may hold family photographs, private messages, work documents, maps, music, memories. But its creation was anything but personal. It emerged from a system designed to reduce variation, eliminate pauses, and transform physical manufacturing into a stream of measurable data. There is something extraordinary about that achievement. Human beings have spent thousands of years building tools, then machines, then computers. Now, we are connecting those computers to machines that can build more tools with decreasing human involvement. The factory is the result of human imagination. Every robot was designed by people. Every algorithm was written and trained by people. Every production line reflects decisions made by engineers. Yet once the system begins operating, the humans move further away from the product. Hands become instructions. Experience becomes data. Supervision becomes software. The factory floor grows darker. But darkness does not mean nothing is happening. It means the machines no longer need to see the world the way we do. They see through cameras, lasers, electrical signals, and sensor readings. They do not hear the rhythm of production. They measure vibration. They do not feel that a machine is becoming hot. They receive a temperature value. They do not look at a scratched phone and worry about the customer. They classify an image as acceptable or defective. That difference may define the future of industry. Machines can make production faster, can make it safer. They can reduce waste and improve precision. But they do not understand why the product matters. That responsibility remains human. People must decide how automation is used, how workers are retrained, how systems are protected, how profits are shared, when machines should stop, and which decisions should never be surrendered to an algorithm. China's dark factory is not the end of human manufacturing. It is the beginning of a new relationship between people, machines, and intelligence. A relationship in which humans may no longer stand beside every product they create. A relationship in which the most powerful worker inside the building may be invisible software. A relationship that could make factories astonishingly productive while forcing societies to reconsider the meaning of work itself. Tonight, the production line will continue. The robots will move. The cameras will inspect. The software will calculate. Thousands of phones will leave the darkness and enter the human world. But as more factories switch off their lights, one unanswered question will follow every product coming down the line. When machines can build almost everything we need, what will humanity choose to build for itself? But that was not even the most difficult inspection. Some solder connections are hidden beneath chips and cannot be examined from above. Manufacturers may use X-ray inspection to look through the component and examine the joints underneath. On a screen, the circuit board becomes a shadowy landscape of lines, circles, and metallic connections. Software searches for abnormal shapes, A void inside a solder joint. A bridge between two contacts. A missing connection. A defect that might survive ordinary visual inspection. Every rejected board becomes information. Why did it fail? Was the solder paste uneven? Was a placement nozzle misaligned? Did the oven temperature drift? Did the component arrive damaged? In a smart factory, the answer should not remain trapped at the inspection station. The data can be sent back through the production system. That feedback allows engineers and increasingly software to identify the source. This is where the factory begins behaving less like a fixed assembly line and more like a living network. Every stage can influence the stages before it. After the circuit boards are completed, other parts of the phone begin coming together. The frame is prepared, cameras are installed, flexible cables are connected, speakers, vibration motors, and antennas are placed into position. The battery is inserted, and the display is attached. Adhesives must be applied with extreme consistency. Screws must be tightened to controlled torque levels. Too loose, and the device may fail.